Alright, welcome back to Let's Go Over Vector Calculus. Today we're gonna be talking about plane equation. So as the name suggests, plane equation is an equation that explains a plane. So what does a plane look like in a space? Well, let's draw a picture. Usually you have a space that looks like this. X-axis, Y-axis, and Z-axis. Right? What is a plane in a space look like? Well, it looked like something like this. Right, so general form of the equation of a plane look like what? So just like equation of a line, you have y equal to mx plus b, where m is a slope, b is a y-intercept. Here we have a general form of a plane in a space too, and it looks like this. So we have ax plus by plus cz equal to d. Right, you can think of a, b, z as a slope in x, y, z respectively, even though that interpretation is not really a correct interpretation, which we'll see in a second what is the real interpretation of a, b, and c. Alright, so quick example look like this. So we just come up with random 4 numbers. In this case I do 2x minus 3y plus z equal to 7. And that is an equation of a plane. Before we move further into the details of all those numbers and how to find equation of a plane, let's slow down and look at this equation in particular, right? So this is an equation that explains the plane, right? So in some sense, we should get a lot of points on the plane from this equation. So what are those points? Well, those points on the plane are triple x, y, z that satisfy this equation. So pretty much if you can come up with x, y, and z that satisfy this equation, that will be a point that lie on the plane. So for example, by just staring at this equation, I let x equal to 1, y equal to minus 1, and z equal to 2. That will make this equation true. So points on the plane are triple x, y, z that make this equation true. Right, so for example, if I let x equal to 1, y equal to minus 1, and z equal to 2, we have 2 plus 3 plus 2, which equal to 7. So that concludes that the point 1 minus 1, 2 is on this plane. Alright, so as we plug in these numbers, x equal to 1, y equal to minus 1, z equal to 2, we have 2 times 1. Alright, so as we plug in x equal to 1, y equal to minus 1, z equal to 2, this equation satisfies because you get 7 equal to 7. Alright, therefore the point 1 minus 1, 2 is on the plane described by this equation. Alright, and as you might guess, the reason of me picking 1 minus 1, 2, there's no reason behind it. You can literally pick x and y to be anything and you can come up with corresponding z, which means that there are infinitely many points on this plane, which makes sense, right? When you draw a plane, there are infinitely many points on them. Right, so let's talk about interpretation of these 4 variables, a, b, c, and d. Actually, we're just gonna talk about a, b, and c because d is kind of like vague what does it mean. Alright, so a, b, c separately are numbers or are scalars, but as you combine a, b, c together into one vector, this vector has a meaning. This vector is actually a vector that's normal to the plane. Alright, so we usually give this guy a name, and that name will be vector n, which is a vector that's normal to the plane. What does it mean geometrically? Let's draw a picture again. Alright, so let's say that this is a plane that I'm interested in. And what is a vector n? A vector n is a vector that kind of look like this. Right? Imagine you have a plane and the vector can kind of point out of the plane perpendicularly. That's a vector that's normal to the plane. So more pictures of the vector normal to each of these planes are like this. This plane is kind of flat, so vector normal can point up. This plane is kind of vertical, so a vector normal is point to the right. And this plane, vector normal, point to the northwest. Alright, so more likely than not, somebody gonna give you a description of the plane but not give you an equation of the plane, and they're gonna ask you what is the equation of a plane. So it's usually your job to gather those information that you're given and find the equation of a plane. To find equation of a plane, you follow the recipe. This recipe has two ingredients. Once you get those two ingredients, you combine them into an equation. And what are those ingredients? Number one is a point at line on the plane. So when you have a plane, there are infinitely many points on the plane, but you just need to find one point on the plane, and that's enough for the first ingredient. For the second ingredient, you need to find what we just talked about a minute ago, which is a vector and normal to the plane. Alright, and this is the point that we should slow down and think back to what we talked about in the previous video. Right? In the previous video, we talked about cross product, and one of the most important property of the cross product is when you cross two vectors, the result vector is a vector that's normal to both original two vectors. In this case, you want to find a vector that's normal to the plane, which means most of the time this vector will be cross product of some other two vectors. Alright, so once you have those two ingredients, a point on the plane and the vector normal, you combine them into one equation, and that equation is as follows. Alright, so the equation is a times x minus x0, b y0, c z minus z0, and that combined equal to 0. With this, let's do a couple examples together. Alright, so let's solve this problem together. So we want to find a plane that contains this particular point 1 minus 1, 0. And on top of that, you want the plane to be perpendicular to this given line. Right? So when you do a problem like this, if you don't know where to start, it's important to draw a picture. Right? So what do you want? You want a plane. You want a plane that contains this particular point, and on top of that, you have a random line that go through this plane and perpendicular to this plane. Alright, so in order to solve this problem, in fact, in order to solve a problem that asks you to find an equation of a plane in general, we follow the recipe, right? So we need to find two ingredients, a point on the plane and a vector normal. Well, a point on the plane is given it to you right away. This is a point on the plane. Alright, but for a vector normal, if you stare at the picture and you try to think what is a vector that normal to the plane, it's almost certain that the vector should be related to this line. And in particular, you want a vector that somehow look like this. Don't make a mistake using the whole line, because the entire line is not representation of this vector. This vector represents the direction of the line, which is just a part after t. Alright, so we actually ignore this part because this doesn't tell you anything about direction of the line. We just use the part after t, which is direction of the line. Now we have found two ingredients, the point on the plane and the vector normal. Now we can just combine them to get an equation of a plane. Alright, so trick to remember is the vector normal is kind of like slope of x, y, z. So this number will go in front of x, y, z. And then inside parentheses, you do variable x, y, z subtracted by point on the plane. So in this case, it's going to be x minus 1, y plus 1, and z. And then everything combined equal to 0. Alright, so this could have been your final answer, except some instructor would prefer you to rewrite this in the form of ax plus by plus cz equal to d. In that case, you would distribute everything and move all the constant to the right hand side. In this case, you will multiply through 2 through, you have 2x minus 2 and do the same for the rest. Then you combine all the constants and then move to the other side. In this case, it's minus 2 plus 4, it becomes plus 2. Move to the other side, it becomes minus 2. Right, so that is definitely your final answer. Alright, so let's do one more example together. Alright, so this question asks you to find an equation of a plane that goes through 3 particular points. Alright, so we draw a picture first. Alright, so as I'm lazy and I don't like to rewrite 101 minus 1 whatever repeatedly, I'm gonna give him a name. So I'm gonna call this guy P, this guy Q, and this guy R. So we have P look like this, Q look like this, R look like this. Alright, So let's talk strategy how to find the equation on the plane. We're going to find two ingredients, a point on the plane and a vector normal. A point on the plane is easy. In fact, we have three of them. We have 3 points, so we can use either one of them. It doesn't really matter which one you choose. All of them should give you the correct answer. In this case, I'm just going to use P because it comes first and number look nice. Now the harder question is how to find a vector and normal to the plane. It's not so obvious what is a vector and normal to the plane. However, if I change the question to can you find a vector that parallel to the plane, then the question becomes easier, right? Because you have this point, you have this point. If you join from P to Q, then that vector will be the vector that kind of like lie on top of the plane, which means that vector is parallel to the plane. And we can definitely find more vectors that parallel to the plane. PR is another vector that parallel to the plane. Alright, but that's not what we want, right? We want a vector that normal to the plane. So far we find two vectors that parallel to the plane. So what we can do is we can just cross product those two vectors, because when we cross PQ and PR, we will get a vector that normal to both PQ and PR. So it will be normal to the plane. Right? Picture wise look like this. This guy normal to PR, this guy normal to PQ. So this guy is normal to the plane. Alright, so now we have a exact plan. Let's do actual computation. Alright, so as we discussed, the point of the plane will be 1, 0, 1. The vector normal will be cross product between PQ and PR. PQ is a vector that started at P and at Q, and the formula is Q minus P. So we get minus 2, 2, 2. Likewise, PR is R minus P. We want to use PQ cross PR as our normal vector. So we compute cross product between these two vectors. Alright, so that's the cross product between PQ and PR. If you're not sure how to compute cross product, please check my previous video on cross product. But here's the result. PQ cross PR is 2, 8 minus 6. We use that as our n, right? So once we have these two information, the answer is easy. We just combine them into one equation. Then that equation is, right? So we have 2, 8 minus 6 as our coefficients, and point in the plane we just subtract x, y, z by 1, 0, 1. All right, and that's your answer. All right, so that's all I want to talk about today about plane equation. Thank you.